हेलो एवरीवन, आई होप यू ऑल आर डूइंग वेल। आज हम इस डेली डोज सीरीज में जो डिस्कस करने आ रहे हैं वो मैकेनिकल और सिविल इंजीनियर्स के लिए एक बहुत ही इंपॉर्टेंट टॉपिक है। द टॉपिक इज ट्रिक टू ड्रॉ एसएफडी एंड बीएमडी, यानी कि शियर फोर्स डायग्राम और बेंडिंग मोमेंट डायग्राम कैसे आप बहुत ही आसान तरीके से ड्रॉ कर सकते हो जस्ट फॉलोइंग फ्यू इंपॉर्टेंट स्टेप और फॉलोइंग फ्यू इंपॉर्टेंट पॉइंट्स। लेट्स सी। सो सिंपल अगर बेसिक पॉइंट की बात करने आए कि व्हाट इज द मीनिंग ऑफ द शियर फोर्स एंड बेंडिंग मोमेंट, जिसको आप बहुत बेसिक टर्म में जानते हो, दैट शियर फोर्स इज नथिंग बट it is the value of algebraic summation of all vertical forces either downward or upward at any given section. That will be the left or right of that section. Means if you want to check the shear force at any given section, that will be the algebraic summation of all vertical forces either upward and downward, summation of these all the vertical forces at that given section is shear force. Similarly, bending moment at any section will be the algebraic summation of all bending moment either left of that section or right of that section. Now let's follow some important step to draw the SFD and BMD. First of all, one important point: how will you calculate the numerical, how will you find the numerical value of the shear force and bending moment? So first of all, we have to represent all the numerical forces including externally applied load and the reaction provided by the support. Like if it is the problem, then in this case first reaction will be equal to F, my dear, and if it will be the value of the L, then second point is, this is well known fact, we must know that moment reaction at this point will be equal to P into F, or we can simply say F into L. This point is A and this point is B. So first important point before starting the SFD BMD, you are aware with all the forces and normal reaction. Now after that, let's come to few important points. Pehla point, you must know the value of shear force and bending moment. Generally at that point, if you want to know the shear force at this point, तो what you will do, इस सेक्शन पे अगर आपको फाइंड आउट करना, you check right or the left with the numerical value, you will just numerically find the shear force. But there are some points, some section जहां पे point load या फिर point moment already लगा होगा. What will be the condition at that point? First of all, you must know what is the behavior of the shear force and bending moment under the point load and point moment respectively. Like SFD jump with the magnitude of the point load in the vertical direction at the point where the concentrated point load is applied, my dear. Like in this question or in this beam of AB, 2 point load are applied. One is at point B and second is at point A, that is the RA. So your shear force diagram will jump in the vertical direction at point A and B with the magnitude of F. If I draw the shear force diagram, you will get the clear cut idea like this. SFD अगर यहां पे बात करते हैं तो you will get the clear cut idea that this will have the magnitude of F and this will have the magnitude of F. Why this A point and B point is having the vertical jump? Because it is the part of point load. Similarly, if I'll ask what is the BMD, my dear, bending moment diagram, then BMD jump at the point in the vertical direction with the magnitude of the point moment where the concentrated point moment will be applied. Two important points. So in this way you can draw shear force, numerical value under the point load and out of the point load. Okay. Second, how will you meet these all the points? For that you must know slope, sir. What is the meaning of the slope? The slope of the shear force SFD at a point is equal to the intensity of the distributed load on that point. What is the meaning of this? At this point, if I want to know what is the value of the slope, then slope of the shear force diagram like this, df divided by x, it will be written by numerical value of the distributed load, my dear. If the distributed load is 0, then my dear slope will be 0. If the distributed load is maximum, slope will be maximum. If the distributed load is minimum, slope will be minimum. Similarly, let's apply the same concept in the previous one. Sir, Between A and B, what is the distributed load? 0. And what is the slope of the SFD? 0. Then this will be the complete SFD diagram in this case, my dear. This is complete SFD. We can draw for it. Similarly, in the same case, if I want to know the slope of BMD at any point will be equal to the intensity of the shear force at that point. Means if you want to check the slope of the bending moment diagram, then it will be equal to the shear force at any given numerical points, my dear. If the shear force over the length of the body is constant, slope of the BMD will be constant. Shear force is 0, slope of BMD will be 0. Shear force is maximum, slope of BMD will be maximum. Let's apply the same concept in the previous one. Sir, between A and B, my dear friend, your value, numerical value or the intensity of the shear force is 0, constant. That's why slope means angle of the BMD must be constant. It means it will be represented by a straight line like this. This numerical value is FL. So one is the magnitude, second is the slope, will give you the proper idea of the correct sequence of the shear force diagram and bending moment diagram. आगे बढ़ते हैं, एक प्रॉब्लम देखते हैं. ये आपका यहाँ पे आप देख पा रहे हो कि ये जो W है इंटेंसिटी, अगर इसको SFD बना दिया जाए, then definitely up to this there is no point load. Here, my dear, there will be a one numerical value of the point load, that is W into L. This value will be equal to RA, my dear. So this value will be equal to RA. Why it is having a vertical jump? Because of point load. Why it is not having the vertical jump between A and B in this problem? Because no vertical load. After that, what is the intensity of the distributed load? Sir, constant. What is the slope? Constant. What will be the slope? Slope in this case will be the constant, my dear. Constant iska slope hoga somewhere like this. Yes. So this is the SFD. Similarly, इस problem को देखें. Simply supported beam AB has a bending moment diagram as shown in the figure. ये गेट में आया हुआ क्वेश्चन है. Then what will be the point? Beam is possibly under the action of the following load condition. Sorry, this is V, C or D. Let's try to check. V option. This is a couple of M that is applied at C. At C point, couple of M is applied. At point D, couple of 2M is applied, because 2M vertical jump, M vertical jump. Absolutely right. Couple of 2M at C and M at D, absolutely wrong. And concentrated load, no, because it is the diagram of BMD, my dear. Bending moment diagram is there. That is only valid. That is the only indication of bending moment, concentrated bending moment at any point of this beam. तो ये आप इसका आंसर आ गया. तो I hope with the help of these 4 important point: 1, intensity of the shear force and bending moment; 2, slope of shear force diagram and bending moment, you will be able to draw, at least you will be able to recognize the correct shear force diagram and bending moment diagram from the load condition. So thank you all. Take care. Bye bye.